Let's understand the third unit, that is the measures of skewness. And we will start it with the definition of skewness. What actually skewness is and how it occurs, what are the types of skewness, what are the meaning or measures of skewness. So first of all, we will understand what skewness is. It is a statistical measure. Let's understand it with the previous slide, that is the meaning and the introduction of statistics. The measures of skewness is the statistical technique. It is one of the technique, just like the measures of central tendency or mean median mode. They are playing a very important role in statistics, and they are also having a relevance in this skewness also. So what skewness is? It is a statistical technique which actually indicates the direction and the extent of distribution of skewness. That means how much the distribution is following the skewness, how this skewness is occurring in the distribution. When we plot the data on the graph, and we will see that where this data is diverging. That means whether it is tilted to the right side of the symmetrical distribution or it is tilted to the left side of the symmetrical distribution. So all this can only be understood when we knew what skewness is. So skewness is actually an extent of tiltedness or the divergence of the data or the distribution of data, which actually shows you whether it is a normal distribution or how it differs from a normal distribution. So let's understand the meaning of skewness. Asymmetry in a statistical distribution. That means when you plot a distribution and you see that some asymmetry is occurring in this distribution. And what is this asymmetry? So first of all, we need to understand the meaning that what this asymmetry, because we are saying skewness is asymmetry. So what is asymmetry? Asymmetry appears as when we plot the curve and this curve appears distorted. When the graph is plotted of a normal distribution curve, when we plot a curve and this is showing symmetry on both the sides, the left and the right side, that is not having any distorted form. But when we talk about skewness, that is asymmetry. That means at that time, the distribution is not symmetrical on both the sides, whether it is tilted to the left side or it is tilted to the right side, or in other terms, the tail of the curve is extended side. So this shows the difference from the normal distribution. So skewness actually is a difference which occurs in normal distribution. Let's understand it with the help of some graphical presentations. What skewness is. You can see here that in this form, in the middle, you will see a symmetrical distribution. As we are talking continuously about symmetry and symmetricalness. So you can see in the middle of the thing, which is showing you the same symmetry, the same position of the curve, the same form of the curve on both the sides. And on the right side, you will see a curve which is having a tail which is extended to the negative part of the graph, which is extended to the left side. And when we talk about the number line, you can understand that on the number line on the left, we are having negative numbers, and on the right, we are having positive numbers. So in the same manner, in this distribution, you will also see that in the middle, the distribution of the curve is symmetrical. That means the position of the curve is similar on both right and left. That is, they are symmetrical. But in the right side curve, you will see that left side curve, you will see that the tail of the curve is extended. This is the thing which actually differentiates the normal curve from these curves. And this distortedness in the curve is called skewness. So positive skewness and negative skewness, they are actually the position of the curve, how they are changing, how the distribution of the data is occurring in the distribution curve. And these positions are actually related with the mean, median, and mode. The three measures of central tendency, they play a very important role in measuring skewness. So in this picture, you can see how the curves are formed and how this mean, median, mode is having a position. We will study it in detail in coming slides. So we will have a better understanding regarding all this. So now we will define what is symmetric distribution. So a distribution in which the values equidistant from the mean have equal frequencies is called symmetric distribution. And any departure from distribution, any departure means any distortedness in this normal distribution, in this symmetric distribution, gives us information regarding the skewness in the data, that the data is not symmetric, that data is having some skewness. And in a perfectly symmetric distribution, the value of these three measures, that is mean, median, and mode, is always equal. That's why the symmetry occurs. The position of the mean, median, and mode is same. They are also equal in their values. But when we say positive skewness, in positive skewness, the value of the mean is greater than the value of the median and mode. And in negative skewness, we will see that the value of the mean is smaller comparing the median and the mode. So these are the symmetrical distributions and unsymmetrical or asymmetrical distributions, which we will see with the help of the charts, which we will study with the help of the measures, mean, median, and mode, and how they are explained, how they will be explained with the help of different forms. You will understand it now. So here you have seen the relationship. Let's understand these curves one by one. This is the symmetrical distribution curve. And here you will see that in the middle, just in the middle of this mean, mode, and median, they all three are written at the same point. Why? Because they are having equal values. And if we are plotting a graph and we are having equal values of these three, then the curve which will form is a symmetrical distribution curve. This is the form of a symmetrical distribution curve, and we also know it as a normal distribution curve. The next is positively skewed curve. Why we are saying it positively skewed? The first reason is you can see that the mean, median, and mode are at separate positions. And the tail of the curve is actually extended to the right of the axis. And right of the axis shows us positive skewness. So this is a positive skewed curve, where we knew that the value of the mean is greater than the value of the median and mode. So this is a right skewed distribution, or we can say positively skewed distribution. This is the form of a positively skewed distribution. So now understand skewed distribution. Just as we have learned the same thing, we have to analyze here. Is now not symmetrical side. So whenever the distribution shows you the distortion and the extension or the tail of the curve is extended towards the left side, that means this is showing you the negative skewness. And here the value of the mean is smaller than the value of the median and mode. And this is called left skewed distribution or negatively skewed distribution. This is the curve of negatively skewed distribution. So these all are the three distributions, that is symmetric distribution, positively skewed distribution, and negatively skewed distribution. Now understand how to quantify this skewness, that how we can measure that how much skewness is existing in the given distribution of data. So it is quantifiable. That means we can measure the value of the skewness. Is it smaller or larger? So the concept of skewness actually helps us to understand the relationship of these three measures, the mean, median, and mode. And the figures are showing you the positions which we have already studied. That is the symmetric distribution, the positive skew distribution, and the negatively skewed distribution. These three are the distributions we have heard. Now understand them in the quantifiable manner. What formulas we have to use, how we have to calculate, and how this skewness is categorized. In the next slide, we will understand it in a much better way, that how this measurement of skewness is related. So this is used to determine, the first concept is determining the skewness on the basis of the difference between these three values of the measures of central tendencies. And what are these? The difference in the values of mean, median, and mode. In the below table, you can see the first category where the mean and mode, the difference of the mean and mode is greater than 0. Whenever this difference, when the difference of mean and mode is greater than 0, this is showing you the positive value. And this curve, this skewness is called the right or positively skewed distribution. Now, in terms of the difference of the mean and mode, if the value is less than 0, if the value comes out, when we find out the difference of the mean and mode, and the value comes out less than 0, then the value is, skewness is negative. And this is showing you the negatively skewed distribution curve, or the left skewed distribution curve. The last is when the difference of these two is equals to 0, and this is showing you that there is no difference in the value of mean and mode. And that's why the curve appears as a symmetrical distribution curve. How the formulas are used, how the further categories of skewness are formed, let's understand it in the next slide. Here comes the categories of skewness. That means types of skewness. The skewness is actually categorized under two parts, that is the absolute skewness and the relative skewness. And the relationship between these two, how they two are related, and what is the difference, we will study that how they are different. What is the difference in absolute and relative measure? So here you can see that what is the difference. When we only take the difference of the two measures, that is mean and mode, that always gives you the value of the absolute measure of skewness. And when we include a deviation, standard deviation, in finding the skewness, that means by the standard deviation of the relative measures of skewness. So the relative measures of skewness are also known as the coefficient of skewness. So this is the difference between absolute and relative measure of skewness. In absolute measure of skewness, we get only the difference, we study only the difference of the mean and mode, the two measures. We can also take the difference of the median. And when we divide this difference by standard deviation, we get the value of we call them as a relative measures. So here in this slide, you can see here, absolute measure of skewness is not widely used. Generally, we use relative measures of skewness because the standard deviation is also included here and more accuracy comes. So it is expressed in the following terms in the form of formula, just like in the first part, A part, you will see skewness is equals to mean minus mode. This is the first way of calculating skewness as an absolute measure. In the B part, you will see skewness is equals to mean minus median. This is the next method of finding the skewness as an absolute measure of skewness. Now the relative measures. The relative measures are also called the coefficient of skewness. And they are frequently used because they are giving us more accuracy, so we use them more frequently. So the A part of this, that the first is, if mode is defined, then the skewness is mean minus mode divided by standard deviation. And if mode is ill-defined, then the skewness is thrice of mean minus median divided by standard deviation. That means if we are not able to find out the value of mode exactly, then we use median. And in that case, the formula changes and the skewness will be 3 bracket mean minus median divided by standard deviation. And the Pearson's coefficient of skewness generally lies between -3 and +3. This is the value of the skewness of the Pearson's coefficient. We will understand all the types of coefficient of skewness in coming slides. So let's understand the next one. Measures of skewness are Pearson's coefficient of skewness. Pearson's coefficient of skewness is actually of two categories. The first, in which we use mode as a difference from mean, and in median as a difference from mean. The next is Kelly's coefficient of skewness, and the last is Bollis coefficient of skewness. In Kelly's coefficient of skewness, we use deciles, and in Bollis coefficient of skewness, we use quartiles. So we will understand all these coefficient of skewness one by one. So let's move. The first is Carl Pearson. The Carl Pearson developed two methods to find skewness in a sample. The first is Pearson's coefficient of skewness, and the formula is a skew. We represent S, and in the suffix we use K. So this is skewness is equals to the X bar minus MO over S, where X bar is your MO is the mode and S is the standard deviation for the sample. Next comes Pearson's coefficient of skewness, and here we use median. As I said, that in Pearson's coefficient of skewness, first we use mode and then we use median to calculate the value. So here you will see the formula as SK2 is equals to 3 bracket X bar minus median divided by standard deviation. So X bar is your mean, MO is your mode, and S is your standard deviation for the given sample. Let's understand the next one, that is Bollis coefficient of skewness. Bolli developed a measure of skewness which is actually based on quartiles. In Pearson's coefficient of skewness, we have used mean and median and mode for finding out the skewness in the data, for finding out the tiltedness of the data, and to how much extent the data is actually being distorted or having a skewness. So that is a first way of finding the coefficient of the relative measures of skewness. The second option we are having to find out the coefficient of skewness of the data is Bolli's coefficient of skewness. And Bolli have defined this skewness in a very clear manner with the help of quartiles. What this quartile actually is. So quartile is when we divide the values, just like a quarter, we can understand it as a quarter. When we calculate mean of the two numbers, what we do, we actually add the two numbers and divided the two numbers by 2. That is called the average of the two numbers. That is the number of observations are given. And this quartile represents the quarter, that means 1/4. So instead of 2, we divide the data by 4. If we are talking about quartile, if we are talking about the formula used for SKB is equals to bracket Q3 minus Q2 bracket minus Q2 minus Q1 divided by the difference of the third quartile and the first quartile. So this is called the difference. Firstly, we have to calculate the difference of the third quartile and of the second quartile, and the third we have to use the difference of the third quartile and first quartile in order to calculate the value of coefficient of skewness of Bollis. So SKB here is representing Bollis coefficient of skewness, and Q1 represents the first quartile The Q2 represents the second quartile, and the Q3 is representing the third quartile, and all these quartiles are calculated one by one. So the first thing which we have to do before finding out the value of SKB, that is Bollis coefficient of skewness, we firstly need to find out the value of these three quartiles. And after that, putting that value of Bollis coefficient of skewness. Let's move on to the next coefficient of skewness, and that is called Kelly's coefficient of skewness. Is, as I said, one of the relative measures of skewness. It's not an absolute measure of skewness. This is a relative measures of skewness. Why this is a relative measures of skewness? Because in absolute measures of skewness, we use actual values, we use original values, and it also gives us original values because we are using mean, median, and mode there to find out the skewness. We are not using standard deviation. We are not using the deviation there. We are only using the three measures for finding out the absolute measures. So that's why they are called absolute. But in relative measures, we use standard deviation for finding out the difference. So that's why they are called the relative measures and also coefficient of skewness. Now this Kelly's coefficient of skewness is the last one among the relative measures of skewness, and this is developed for the process of finding out the skewness up to the extent by using percentiles. How the percentile can be used to find out the values, how the deciles can be used to find out the values. So first thing which we have to understand is that Kelly's study actually based on the two things, that is percentile and deciles. He has used percentiles first for finding out the Kelly's coefficient of skewness, the first Kelly's coefficient of skewness using the percentiles. So the formula given here is SK is equals to, SKK means Kelly's coefficient of skewness, and this is equals to P90 minus twice of P50 plus P10 divided by P90 minus P10. And what this P90, P50, P10 actually represents. So here you will see that this SKK is Kelly's coefficient of skewness. This P90 represents percentile, 90 percentile, and this P50 represents 50 percentile, and P10 represents 10 percentile. So this is the thing which we have to calculate before finding out the value of Kelly's coefficient. If we are having all these values with us, then it becomes easier to find out Kelly's coefficient. We just have to apply this formula in order to calculate the skewness based on percentile. This is the important one because it is giving us an in-depth knowledge regarding the use of mean, median, mode, regarding the use of percentiles, regarding the use of deciles and the quartiles. So on the basis of deciles, this skewness is D9 minus twice of D5 plus D1 divided by D9 minus D1. And what this D9, D5, D1 represents here. So firstly, we will understand the meaning of these. That is SKK. Here gives us the meaning is Kelly's coefficient of skewness. SKK again giving you Kelly's coefficient of skewness, and the D9 value represents you the 9th decile. The D5 represents us the 5th decile. and the T1 represents us the first decile. So all these deciles first will be calculated, and in order to calculate these values, we just need to find out the first part of the calculation of these coefficients of skewness. Just like we started, again we will start from the absolute measure. The first thing which we have to do for finding out this skewness is the calculation of the mean, the median, and mode of the data. So first of all, whatever the data has been given, we just need to calculate the value of the mean, median, and mode. And the second thing which we have to do for absolute measure is to plot that data now. We just make a graph of that data. We plot that data, the frequency distribution given on the graph. And after plotting, we will see what form of distribution we are having. So as the first condition of the absolute measure, the data distribution may be symmetrical, asymmetrical, or so we can say that the distribution is based on the skewness of the relative measures and the absolute measures. So these two measures helps us to understand how this asymmetry occurs in the distribution and how this asymmetry explains us that how the data has been distributed, how the curves are forming their are changing their forms, where the data is tilted, whether it is symmetrical, asymmetrical, that means positively skewed, yeah, negatively skewed, or symmetrical. So this is the thing which we can understand as a skewness, which actually helps us to understand the how to calculate skewness, how to differentiate skewness, and how to find out the values of skewness. So in the next lecture, I will explain you how to calculate skewness by using our averages, that means mean, median, mode, our measures of central tendencies, and these percentiles, deciles, and quartiles. They all will be explained in the next session to understand how this skewness is calculated, how to quantify the skewness. So all these measures will be applied there one by one, and we will understand in depth that the calculation based on the data given and how this asymmetry occurs in the data. This is a detailed explanation of the skewness, and the problems will be discussed in the next session in detail.